Finding concavity and points of inflection graphically. In this section of lessons on function characteristics, we have been largely focusing on using qualitative methods. For example, when we talk about absolute extrema, we talked about looking at a graph to look for the highest or lowest point of a function over a given interval. Why is that the case? The reality is that we need some calculus to mathematically or quantitatively calculate these function characteristics. We are not helpless, even as Algebra 2 students. Today, we will be talking about how to find points of inflection graphically. We will start with the basics. We are going to talk about points of inflection and concavity. We will start with functions, and then we will move in closer to intervals. Before we dive into points of inflection, though, we want to be able to recognize the difference between a concave and a convex graph. You may remember these terms from a while back when learning about lenses in school. A concave lens is one that looks like a cave. We can apply that here too. Here's an example of a concave lens, or a concave graph, sorry. Kind of looks like a cave, doesn't it? With a concave graph, or concavity, the graph opens downward. Some people also call this type of shape concave down. You guessed it. If we have a graph facing downward, we need to also have a graph facing upward. Here is an example of a convex graph. The graph opens upward or is shaped like a cup. Some people also call this shape concave up. Either one is fine. Now that we understand the difference between a concave and convex shape of a function, we can move on to the next big idea in this lesson, points of inflection. So far, we've only been looking at functions that are either fully concave or fully convex. With the power of the points of inflection, we can have a function that has both concave and convex parts. Once you learn what points of inflection are, you will probably realize that you've seen them before numerous times without even realizing it. A point of inflection is the point at which a function changes direction. That means it can change from concave to convex, or vice versa. The units between the points of inflection are called the intervals, which you have heard before when we talked about increasing and decreasing intervals of functions. Remember earlier how I was talking about qualitatively finding function characteristics? That is what we will be continuing with this lesson. However, I want to mention that you can find points of inflection quantitatively. We don't have the mathematical skills yet to be able to use math to find the points of inflection, but that's okay. We will learn about it soon when we tackle calculus. For now, we will continue to use qualitative methods. Here's the function y equals x cubed. We can see that the graph changes direction. On the left side of the y-axis, it looks like a concave function. On the right side of the y-axis, it looks like a convex function. That's weird, but that's okay. The point at which the function changes direction is called the point of inflection. For this graph, the point of inflection is at the origin. Next, let's look at a function with multiple points of inflection. Do you recognize this graph? It's a graph with a sine function. I've taken the liberty to label two of the points of inflection for you. The sine function is infinite, and it has an infinite number of points of inflection. But do you see how the graph changes direction at the points of inflection? In the sine function, the graph is constantly changing direction, and each time it does, we find a new point of inflection. Let's look at this more complicated example. I have labeled the 2 points of inflection for you. This function is only over the interval from x equals -2 to x equals 1. We are going to move on this graph from left to right and identify the intervals that are concave or convex, and point out the points of inflection. As you can see, the first part is convex. You may recognize the beginning of a positive quadratic shape. Then we hit our first point of inflection at approximately x equals -1. So right here is our first point of inflection. And here we have what looks to be a convex shape. For the next interval, we can see that it is concave right here. That may be hard to see, so you might need to zoom in, but the arch starts to turn downward right here. So that would make this interval concave. Then we reach our point of inflection on the origin. The last interval is clearly convex. And that is the entire function. You can use this qualitative method to identify concavity and points of inflection by moving systematically from left to right for a given function. If you get confused, remember that for concave functions, the function opens downward like a cave. For convex functions, the function opens upwards like a cup. Nicely done. You've learned about using qualitative methods to find concavity and points of inflection.